Hello. Hello. Hi. So I'm going to show a little bit around using the Chrome developer tools and how to have a productive workflow in developing, also capturing kind of developing for the mobile web, and some more performance stuff. So first up, we're going to dive into a workflow. And so optimizing how fast we can iterate when we're doing development. To do this, I'm going to demo. And so I'm going to try and put this in my pocket. How's that? Yeah, does that work? OK, it's not awkward at all. All right. So we're going to come out to this. This is a site that I work on with some friends called HTML5 Please. And let's say I just want to make some changes on this site. So I'm just hosting it. I have like a local server on localhost 8000. And I want to make some changes. All right, so let's see. I'm going to open up the Chrome developer tools, select this, and make some changes. Maybe I'm going to bring the font size down a little bit, add in a new color. It doesn't look very good. Let me try. I'll change this over to blue for now. OK, sure. Now, normally how this works is that I will take this and take the changes that I like, right, and copy them, and then come over to my text file, say it's like right here, and paste it in, right? And that's like how I would probably normally do it, but that's not very good. So what we can actually do is we can combine the two. And so what we're going to do is use a new feature called Workspaces. And this allows me to kind of mount in my code, my local development folder, into Chrome and just be able to save directly back to disk with all my changes. So this is how it works. First, I'll just refresh the page. OK. And now I right-click in the Sources panel, and I can select Add Folder to Workspace. So everyone can see this down there. Now, that comes up, and I want to select which folder I'm going to bring in. And here is my local folder for this project. So I say yes and allow. All right. Now we can see it here. And so here's my local folder. And so this has everything, all the files in it. Say, for instance, my configuration for SAS, my git ignore. Like I can make any changes here. And also, if, say, for instance, I make a new file, that also comes in, and I can see that. So hello, hello, and then, right. So nice. So I have a mapping between what I have on disk and what I have inside Chrome, and full persistence. But where this gets interesting is being able to manipulate the styles or whatever else like we all want to. So let's do some of that. So I was making some changes here before, and we'll bring down this font size and select this guy. And we'll change him. Ooh, yeah, that's pretty. That's nice. I like this. So that's good. And now, when I come over to one mistake. One thing that I need to do once I mount in this folder is to map it. I need to map it to my other assets. So I have my script that's coming from localhost. But I need to tell Chrome that it needs to match. So what I do, this is a one-time setup, just I need to map file to local resource. So I select the one that matches, and that's it. Yes. OK, OK. Now, I'm going to come back up and make this change again. And I'll add in a new color. And now when I come over to my code, you can see my font size is now 3M my color is blue. I'll add in a few more. Border, 10 pix solid gray, background, I don't know, green? Green? Not improvements, but they're coming right in. So this is full persistence in there. Now another way I could do this is I could come in to Sources panel and make any changes. One new change that we just added is if you hold down the Alt key, you can now just hold down Alt and change these numbers just right with up and down. So I can make changes here, or I could come over to my text editor and say, I don't like green anymore, I really want purple. I hit Save in Sublime, and I come back here, and it's like, oh, sure, no problem. So this is really nice. If you do want to continue to develop over here and make any changes, and it'll just come in immediately. So this is pretty powerful, and I've showed it with CSS here, but it's also really useful with JavaScript. So on this site, if I type in this box, we filtered down the results of what's showing up here based on that. But if I want to get a better understanding of how that works, maybe I want to add some console log, like debug statements to figure this out. So let me just close these. I'm going to hit Command-O and look for my script file. And yeah, actually, this is perfect. So, right. So right now when I type here, I want to get an idea of kind of how these values come into the JavaScript that's handling this. So what I can just do is immediately enter in a console log statement. And so I'm in the update search method. And so I'm just going to blog that I'm there and see what the value is. Now, when I hit Command-S right now, what Command-S is doing is it's persisting this change to disk, and then it's also telling V8, the JavaScript engine, that it needs to now evaluate this new definition of this file. So I'm hitting Command-S. I'm not refreshing the page at all. And when I type here, it immediately changes. So V8 has the new definition. And now if I go over, and I'll just double check, here's my changes that I made to disk on the styles. And yep, and here's my change down here to the JavaScript. So this is nice because I can go really fast. I'm not refreshing the page. I'm changing both CSS and JavaScript and persisting all the changes that I like to disk. One thing I didn't show is, let's see if this works. We have full undo and redo. So it's going to try. Oh, no, I refreshed the page. Damn. All right, so if I make these changes and I don't really like them, I can just hit Command-Z to bring them back. So whether you make changes here inside the DevTools or changes over here, you can just hit Command-Z to kind of work your way back, and all those changes will be maintained in the files. So this gets really powerful, right? I can edit the entire project, whether it's Markdown files, PHP files. I can do it right there in the DevTools. So the DevTools kind of becomes my editor. All the changes persist to disk, full undo, redo, and it's nice because I can maintain my context. If I'm setting breakpoints in my JavaScript in the DevTools, I can also edit right there and make those changes and save those to disk. All right, the next thing I want to show is the DevTools support for Sass and less. Who writes their styles using Sass? Raise your hand. Yes. Less? Less? A lot more people using less. Good. OK, this was just added like 2 weeks ago. But let me show how this works. So Now, one thing that you might notice is that, let's say I'm going to select this little item right here. So this is the little use item is what I'm selecting. And if we look over here, we have a few styles on it. We have just this green and a green that's a little darker and a green that's a little darker than that. But you can see actually where this definition is coming from is from an SCSS file. So it's not a SAS file. It's not a CSS file. It's it's a SAS file. So let me click through on that and see what's going on. Oh, let me try that once more. OK. So here we're actually jumping to the definition of the mixin. So the mixin that I wrote for this SAS kind of does some things. I have a variable coming in with this color. Here's the background box shot on border radius, but it's taking this color and it's kind of darkening it here. It's darkening it here. So we're doing some nice things in the SAS. But if I want to make a change to this green, what I could do is just take this and change the color, but that doesn't really work, right? I have this stuff here. So clearly, I'm not going to be able to do this by just editing the CSS. I need to edit the SAS, the original SAS. So let's try that. So if you hold down the Command key or the Control key, you'll see a underline. Let me zoom in on that. Oop. So this command, this indicates that you can jump to the original location where this is defined. So here, if I Command click on background, I jump to where the background is. But I want to change this color. So I want to Command click on that background color. And now, whoops. Well, what I'm expecting it to do is to jump to this color definition, which is in my variables SAS file. So what's cool here is if I want to make this change to this variable definition, let's say I'm going to turn it to red, I just hit Command S, and I wait, and I get my changes. So I just changed SAS in the DevTools. And what happened on the back is over here, I actually have a tab that has a little watch just to monitor changes and have Compass and SAS recompile the new CSS. And so that happened. And then DevTools picked up on the fact that the CSS file had changed and just refreshed it. So now I can make any sort of change in the SAS. And it takes a little bit of time to actually, there we go, for the change to happen. But this is really nice because I can go very fast now. All right. So that is a little bit of the DevTools support. Like I mentioned, we've had support for SAS for a while. And the guys behind the Less project just added support inside their compiler for creating source maps, which is what powers this whole thing. So we have support for both. So this whole story really creates a compelling development environment where I can just, anywhere that I type, I can style, see the immediate results. Everything's persisted to disk. And I get a lot of immediate feedback. All right. But I want to take this stuff and go mobile with it. So let's do that. So we're going to come over here. And I have my phone. And this is my password. All right. So let me just refresh this. OK. Cool. Focus. Yeah, good. Now, I want to do this development, and I want to debug what's on my phone. So let's try that out. So come over to Chrome inspect, you can also just type about inspect. And now, let's see, I want to get this on the screen at the same time. Here we go. Now let's plug in the phone. Yeah, whoo. All right, cool. So I just found my phone. Now, if raise your hand if you've done remote debugging with Chrome on Android before. OK, cool, a few of you. Before, it required some things around downloading the entire Android SDK. It was really painful. Now, just plug it in. It just works. So we see Chrome 31 is now here. And I want to load a page. So let's see, I don't know, load neighbor.com. Sure. All right, cool. All right, so I'm going to just hit inspect. And so, all right, here's the DevTools, the full DevTools. And so if I come over to timeline and I start a recording and I scroll the page, I'm getting all that stuff. So that's really cool. How many, raise your hand if you have one of these cameras here that can, take a picture of your camera and put it on your, OK, probably not. So we thought that this is a problem, so let's solve this. So I'm going to kill this video. And I'm going to go into settings and turn on a new experiment that we've been working on. This is called Screencast. This is the first time that I've ever showed this publicly. So this is it's the debut of this feature. I'm really excited. All right, so what we do is we close that down and bring that back up. And now, yes. So this is really cool. So I have, as I just scroll, I can see immediately what's going on. So I can just do the same thing. Right. So that's really nice. I don't have to go back and look down at the phone and come over here. It's just all right here on the screen. So let's do a search. So I can type and be like, Chrome. OK, but this is taking a while. I'd much rather just type here on my keyboard. So let's try that. OK, cool. So I can type. And let's see. Let's try. Yeah. All right, I can click. And the last thing I want to show here is that I can just inspect element, and inspect element works too. So I can just select the item, and my DOM view comes up. So this is really powerful. This means that I don't have to go and muck back with my device. I have it all right here on screen, and I have the full DevTools to support it. But let's go back to the project that I was developing before. It was, let's see, it was this, localhost 8000. And so we'll just open up a tab with that and inspect it. So one thing, there we go. So one thing that happens a lot is that you want to develop localhost 8000, but your phone, doesn't know what localhost 8000 is because that's your machine. So the feature that we have available now is port forwarding. So you can just say, I want whatever on this machine, and I want to have it available on my phone. So now we have this project right here on the phone. And everything that I showed just a moment ago with Workspaces still works. So let's try, first up, we're just going to select this text and try a different selection color. Ooh, yeah, that's nice. Something like that. OK, good. Come over, select this text, this H1, and again, we'll change the font size to be really big. Yeah. And what's great about this is that these changes that I just made here while I'm debugging my phone, these just save to disk. So if I now come over to my other window, this one, see, this one, I refresh. Whoa, yes, cool. So this means I basically can choose where I want to develop, and it's all saving back to disk, which means that I can go really fast, make changes, and not kind of worry about where I have to copy what. All right. So this is how remote debugging works now. We have a very powerful feature set. Everything that you can do in regular developer tools, you can do while you debug your phone. The screencasting feature, port forwarding, and it's a lot easier to set up than it ever was before. All right, I'm going to move on to performance. So first up, these are actually graphs from Internet Explorer. They were talking about kind of what sorts of operations the browser does when it's loading and using pages. So they looked at kind of the top 100 sites and the top AJAX sites, JavaScript-heavy sites, and looked at what the browser is busy doing on those sites. And looked at, in these cases, the amount of time actually executing JavaScript is pretty low. A lot of time is just spent in layout rendering and kind of manifesting the page. So this basically means that JavaScript is often not the bottleneck in many, many cases. And you want to be able to look at and get an idea of the performance of the other parts of what the browser has to do. So not just running the JavaScript profile. So let's talk about how some of that works. And to show it, I'm going to do a little demo where I do a performance audit of this site. So this is a festival in Canada. And they have a nice website, but it could be faster. So I loaded up the page. And as I scroll down, it might be hard to see, but it's a little, like, it doesn't feel very smooth as I'm scrolling here. It feels like it's stuttering. So I'm going to take a look at the DevTools and see what they're telling me about this. So I'm going to go to the timeline. The timeline is where you want to start all of your performance investigations. And I'm going to start recording. And here we go. So immediately, this is giving me back a lot of information. And what I'm seeing is a lot of purple here, right? And the purple, when I look, is a lot of recalc style. Let me raise this up just so that everyone can see. So recalc style in jQuery. OK, interesting. So we can look at what exactly the call stack is that forced this. Add class. OK, so we're manipulating the class of an element. And we come down to where the actual application code is. And let me just click through on that. And it went right here. So the cursor is telling me that this is where it happened. We called toggle class. And we're calling toggle class inside the scroll handler. So on every single scroll event, we're manipulating the class of the HTML element. This, you know how people tell you to not touch the DOM too much? This is usually why. You're manipulating the class of the HTML element, and what it's causing is a lot of performance problems. All this purple here. So let's try changing this and fixing it. One quick fix that we can do is using, instead of toggle class, I'm going to use an HTML5 API, here we go, called class list. And class list.toggle actually has the exact same method signature, the same arguments as toggle class. So we can just keep that there, keep this. And now I'm just going to hit Command S. And And that should just send it immediately to the JavaScript engine. So now, when I come back to timeline and I hit record again, OK, cool. So big change, right? There's no more purple. There's no more recalculate style. Still, there is a good amount of green, of painting happening. So we want to figure out what that is. So I'm going to go into the DevTools settings, and I'm going to turn on a mode called Show Paint Rectangles. I'm also going to turn on Show Composited Layer Borders. I'm going to get into what these mean in a second, but I just kind of want to figure out what's happening. OK, interesting. So you can see as I scroll, there's this rectangle above the top nav. So it's being repainted. Every single time I scroll, the browser has to refigure out what the top of that looks like. It can't just put the layers on top of each other. It's doing a lot of work here. I want to make that easier. And so I'm going to try a few tricks. So we're going to come in here. Here's the main navigation. A quick tip is you can hit H on the keyboard, and it'll just hide whatever element you're looking at. All right. So we have this top nav, and it's position fixed, right? Or here we go. It's position absolute. Interesting. Let me try and see if we can fix this. So I'm going to change this to position fixed. And, OK. Here we go. All right, position fixed. And I'm going to use a trick called promoting a layer. And you might have seen this before. It's often called the translate Z or the translate 3D hack. So now I've just promoted it to a layer, and you can actually see this gold border around it indicates that it's now a layer. And now when I try scrolling, I don't have that red paint rectangle around it. And I can verify here in the timeline by just scrolling up and down. Yeah. And I've taken care of that concern. This particular trick often happens with position fixed elements. And right now, it's only particular to Chrome on desktop. Pretty much all other browsers, including mobile browsers, have ways of dealing with this. But it's something to look out for. All right. So those are a few of the tricks that you can use. But I want to walk through some of those operations were. The first that you see is recalc style. So recalculation of style gets all the style rules in the document, whether it's in a CSS style sheet, an inline style, a style tag. It gets all of them. And then it looks at what all the selectors are and matches them against the DOM. It figures out what elements it needs to evaluate the style of and gets a computed style of every CSS property for every element in the DOM. All right. Once it knows what all the styles should be, it needs to apply it. And this is called layout. Layout is the first step, where it just figures out the geometry of where everything goes in the document. I want to show a problem called layout thrashing. Layout thrashing happens because when a browser is laying out the geometry of the page, it also needs to figure out if you ask it for the current position or the current width, the current size of an element, the browser's like, oh, OK, I'll go get that. But then if you change something, it relays it out. And then there's a bad pattern that people often fall into. I'm going to show a little demonstration right now. All right. Come on. OK. All right. So in this little demonstration, I can change the size of the green rectangle. And when I hit set block width, it goes and it sets the width of all the other text blocks. You can see, click. It takes a while. Now, there's another way to do this. And if I try that way, much faster. OK, so what's the difference between the two? Let's open up the DevTools. First, I'll turn off these guys. And I'm going to start a timeline recording and set that block width. Ooh, OK. So here you can see that big pause, that big chunk, after I clicked. All right, so I'll bring this up. Now you can see here this pattern. Recalc style layout, recalc style layout, recalc style layout. And there's this little warning indicator telling you that there might be a problem. And it says, forced synchronous layout is a possible performance bottleneck. And you can see right here what it's telling you. There was a layout that was invalidated at line 125. And the layout was forced to be recomputed at line 124. So let's go look at those lines. All right. So here is line 124. What we have is a big while loop. It's just looping over all those little text blocks. And inside that loop, we get the offset width of that green block of this guy. And then we come in and we set the width of each element. So we're setting the width of each element. We're going and looking at the size. We're setting the width, going and looking at the size. In the fast version, which is right here, we go and we look up the width of that block once. And then we go and we do all of our sets where we set the widths. So the big thing to learn here is that if you need to figure out the dimensions, if you need to ask the DOM for the dimensions or sizes of an element, try and do that only once and not interleave it with changes that you're making to the DOM. But if you ever have a question, just open up the timeline, and you'll probably end up seeing this pattern. It happens a lot of times. All right, the next is paint. Painting often captures a lot of time. We were seeing before all the green. There's a lot of time spent in paint. There's a few ways to debug when you're having a lot of painting. And the first is continuous paint mode. So continuous paint mode allows you to look at how long it takes to paint. And it allows you to kind of figure out what is contributing to it. So I'm going to turn it on now. See right here, enable continuous page repainting. All right. So this is it. What it's telling me is it's taking about 3 to 4 milliseconds to paint this page. And it's just doing it over and over again. I can verify that down here by opening the timeline. All right. So what this allows us to do is we can now make some changes and figure out how to kind of manipulate what that looks like. So I'm going to come over and turn on some box shadows. Wow. OK, cool. So box shadows definitely take a lot more time to paint. And so that's why we're seeing the graph really spike up. I could also, let's see, try. If, for instance, I take this box shadow, and right now it has a blur radius of 120 pixels. If I just change that down to 20 pixels, it's faster. Bring it down even more. Yeah. So this allows you to kind of see what affects paint. Oftentimes, box shadow does currently impact paint cost quite a lot, but Chrome is always improving things, so that might not be the same case tomorrow. The next situation I wanted to introduce is, we call it paint storms. And paint storms basically refers to the browser is painting the page a lot, but it really shouldn't have to. So let's take a look at a situation where that happens. So I'm going to come in here and set this background. All right. I'm going to come over to timeline and turn off continuous paint for now. And if I turn on show paint rects, you can see, well, it's a little hard to see, but the entire screen is repainting on every single scroll. We can see the paint action down here. It has to figure out, let me turn on a box shadow too, so it hurts even more. Ugh. Yeah, that feels bad, right? Ouch. All right. So what's happening is that there's the fixed background behind all this content. And the browser is being really slow in figuring out, on every single scroll, it is recomputing how that looks underneath all this content. I'm going to quickly try and fix this. We'll see. I'm going to take the fixed background that is on the body, and I'm going to create a brand new element. Let's put him right here. And I'm going to cheat, and I have some code. Hey, what? No, definitely not. OK, there we go. So I have my div, and let's drop in that. OK, yeah, that seems pretty good. With 100% cover. There we go. OK, cool. Now, so I've basically shifted the background from the background of the body to a div that's within it, and just put, z-index is -1 to kind of put it behind everything. And I use that trick again, the translate z trick, because it is position fixed. And so you can see now there's no red outline, and if I look in the timeline, there's no activity. Just to kind of verify that this indeed does change things, I take off that translate z. It's back. It's gone. Cool. So that can be a trick for fixed backgrounds or fixed position elements. But the big thing that you want to look for is turning on show paint rectangles and seeing if the entire page is flashing or one section of the page is flashing while you're scrolling the page or while some behavior is happening. That's often a way there is some improvement that you could make, and you want to investigate what you can do there to make the experience a lot smoother. All right. Moving forward, if this is, I just kind of want to point out, if you spend a lot of time in the timeline, you want to get a flow for what operations are supposed to happen, and this is the correct kind of flow. So oftentimes you'll have JavaScript that runs. After that, the styles need to be recalculated. The geometry of the page needs to be laid out. Maybe there's paint set up. We have to show what things look like, and then we have to kind of send it to the GPU and composite layers together. When doing performance work with the timeline, this is kind of a cheat sheet for what tool to use when. If you profile with the timeline and you're spending a lot of time in script, just go to the JavaScript profiler. If you're spending a lot of time in layout, look and figure out if you have layout thrashing, things like that. Paint, I covered this. Paint rects, layer borders, use continuous paint mode. And there's a pro-level feature called About Tracing, which dives into the guts of Chrome that you can use if none of these are working for you. All right. But how do these all map to CSS? Like just your general CSS, the CSS that you write. This is the CSS selector gets recomputed in recalc style. The height, because it's the geometry of the element, it's what size it is and its position, that affects layout. And a text shadow doesn't affect the layout of the page at all. It only affects how it looks. It's a visual effect. And so that's captured underneath paint. So there's actually, between all the different CSS properties, they affect different parts of all these operations. Transform and opacity can be operated 100% on the GPU. This is really good. Basically, GPUs are fantastic at doing these sorts of operations, but everything else needs to go through a little bit more work. Box shadow, border radius, and background just need to be painted, but they don't affect the geometry, the layout. And like I mentioned, width, margin, border, those sorts of things, those do layout. So if you're doing an animation, like you're animating an item across the page, or you're increasing the height of an element, the less work that you can do, the better. If all you can change is just the transform and opacity, it's probably going to be a lot faster than if you try and animate left and top or width. So try and animate these guys. Here's another way to look at that. There's 4 things that a browser can transition really fast. They can scale, move, rotate, and fade. That maps over to our transforms and our opacity. Sometimes you do need to apply that translate Z. Everything else that you translate, that you animate, might take more work, and so just be aware of that. Especially on older phones, animating something like left and top or width is it's gonna be slow. So if you want things to be fast on mobile, try and animate only those things. All right. I just want to quickly try and show the difference of what this looks like in the DevTools. I have this table here, and this is kind of a fun little app that lets you see how different CSS properties animate. It's nice. Let's take a look at what changes all these things affect in the web browser. So open up the DevTools, and I'm down here. All right. So here we have left. Here we have top. We're animating the top. And here's transform. And if I come in, I'm going to turn off show paint rectangles for now and go to timeline. Yes. I'll do a recording. There we go. So here in this recording, you can see we're going through recalc style, layout, paint, composite layers. When I do transform, whoops, all we're doing is just painting and composite layers. And that's all the work that we do. Yeah. So the best ways to do an animation, if you can, is to not use JavaScript. If you can do it completely in keyframe animations or a CSS transition, browsers can optimize that really, really well. Once you use jQuery to animate, it's going to be a lot slower because the browser can't predict kind of what's happening next. All right, let's move on. I was going to talk a little bit about how to figure out when sites are done loading. And there's a fantastic measurement, and it's called the speed index, that basically evaluates how long it takes to get a visual on the page of what the page is supposed to look like. And it's a really nice metric and captures kind of when the page is completed loading a lot better than window.load or DOM content ready. So it's called the speed index. And right now, you can use web page test to look at it. Web page test, raise your hand if you use web page test before. A few people, yeah. It's really fantastic. So I'm going to show quickly kind of what the results look like. So I did an analysis for a site called Retail Me Not. And in it, you get the network waterfall. But a really nice view is the film strip view, where you can see this network waterfall against the visual representation. So I can scroll and kind of see, as resources were loaded, what did the page look like? And here at 0.9 seconds, we finally got to see something. It can also capture what the Chrome DevTools timeline looked like for this exact recording. The Chrome DevTools is a web app, so we can just load up the Chrome DevTools using that recording and see if we see any of those patterns. Big layout, timers. Yeah. This site was really fast, so there's not much to optimize. And lastly, they also do show and capture the speed index. So a really nice thing that you can do is have web page test track the performance of your page. Like do a test once a day, and you can see its progress over time and see if you're actually improving how fast that page loads. It's possible to run a completely private instance. You can ask a Chrome or an IE8 or IE9 in the cloud to evaluate the page, or you can also run it internally if you want to evaluate it against a site that's in development. All right, so to sum up, users expect things to be fast. Under 100 milliseconds is good for showing a user that it's happening, but it starts to get really stuttery when it comes to animation. Anything longer than 1 second is just going to take way too long. So you want to be really attuned to how fast your page loads and how fast the interactions are. These are some aggressive but good goals to kind of think about. When it comes to delivering an experience on mobile, you really want to show the content that's above the fold, the content that the user sees when they first load up the page in under 1 second, from after they click a button, click a link, or finish typing in a URL. Under 1 second is a good goal. One of the things that has to happen to be able to do this is serve all the content that you need to for that above the fold content in under 14K. That includes any CSS that is required for that section. But if you have CSS that applies to the rest of the page, you can defer that and send that part later. Oh. Oh, OK. All right. Lastly, a maximum of 200 milliseconds for the server to respond with the page. 60 FPS scrolling, 60 FPS transitions, keep things fast, and a speed index under 1,000. I showed you a lot of things in the Chrome Developer Tools today. We have been working on our documentation, so this covers a lot of the functionality that's in there, things that you might not expect. So I encourage you to go check that out. And everything that I showed is available in Chrome Canary today. And one more thing, is Jimmy Moon here? He is. Oh, good. OK, great. Hi, Jimmy. Jimmy's awesome. And we met actually at Google I/O not too long ago. He's a JavaScript developer here in Seoul. And he's been really active on the Yeoman project. He also maintains the generators for the Chrome apps and Chrome extensions. And a lot of people use these. He's also working on a brand new site that I encourage you to check out. It's called Chromist. And he wrote about Polymer just the other day, and it's really fantastic. So I encourage you to check that out. And I just wanted to thank you, Jimmy, because you're fantastic. So thank you very much. And that's it for me, too. Thank you guys very much. Appreciate it.